Inequalities Test Review, page 1. Every graph tells a story. It's an important story with lots of information. It's straightforward when we take our time. We remember that we began life in Algebra 1 graphing equations. For example, when we would graph y equals negative 3x plus 5, we could say, for example, whatever x is, and we don't care what x is, whatever it is, negative 3 times that number plus 5 is our output. That's an equation. What we keep is the slope and the y-intercept. The slope is negative 3. The y-intercept is 5. When they ask about line, they are saying, is it solid or is it dotted? Now, y equals negative 3x plus 5, of course, is a solid line because we can use any real number for x. The square root of 2, the square root of 17, pi, whatever. And negative 3 times the square root of 2 plus 5 gives our output y. When y is strictly less than this expression, then our line is dotted because y can be any value less but not equal to. Do we shade above or below? We shade below because y is less than, and our y-axis is the vertical component. So we shade below. Let's graph this and see what happens. The y-intercept is positive 5. 1, 2, 3, 4, 5. The slope is negative 3. Negative 1, negative 2, negative 3, positive 1. Negative 1, negative 2, negative 3, positive 1. We want to be very careful with this because we want our graph to be able to predict other values. So now we draw our line carefully, 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 because if it's sloppy, we cannot use the graph to predict. So what's the point? Now, we notice that I put arrows on the line to infinity and beyond. The line goes on forever and ever and ever. Let's test the point 0, 0. Negative 3 times 0 is 0 plus 5. Is 0 less than positive 5? It sure is. So we include everything forever and ever, everywhere, 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 everywhere. Okay, the rest will go more quickly. Problem 2. Y is greater than 9x minus 5. Our slope is 9. Our y-intercept is negative 5. Our line is dotted. Do we shade above or below? Let's draw the line and find out. Negative 5, negative 1, negative 2, negative 3, negative 4, negative 5. The slope is 9, 5, 6, 7, 8, 9, and over 1. Solid or dotted? We decided dotted because our output can be up close to that line, but it cannot be bigger. Now, is 0 bigger than -5? Yes, it is. So 0 is included, and above and below is a little tricky when we have a graph like this. So let's say above, but we can also say to the left. Problem 3. There are a couple of ways to do this. We could put it in slope-intercept form. How would we do that? X plus y greater than or equal to 3. Subtract x from each side. That gives us y greater than or equal corrected my mistake. Subtract x from each side. Y is greater than or equal to -x plus 3. So if we do it this way, our slope is -1. Our y-intercept is 3. What if we don't want to do that? Well, let's test what happens if x is 0. If x is 0, what happens to y? Y has to be greater than or equal to 3. If x is 0, y is 3. Now what if y is 0? If y is 0, then what's x? X is 3. That's convenient. Okay, if we do it in this fashion, what do we get? Well, we have 2 points. How many points do we need for a line? Oh, that would be 2. So, 0, 3, and 3, 0. Is that the same as the slope of -1? Let's check it out. Now, do we need a solid line or a dotted line? Well, x plus y could be greater than or equal to, so it's a solid line. Above or below? Well, is 0 greater than 3? No. 0 is not greater than 3. So 0 is not part of the solution set, so we must shade above. End of page 1. Everything else will go faster.